Recursion. Recursion. So what about recursion? Recursion is perfectly okay for a function to call itself, and as long as it doesn't do it so often that it overflows the stack, and the function that calls itself is called recursive, and recursion allows some functions to be written in a different style, by the way. And take for example this alternative implementation of power, like this example now. Function power, open parentheses, base and exponent, and if exponent equals 0, and return 1, semicolon, then else, return base multiply power, open parentheses, base and component minus 1, and console.log will be power 2 and 3, and will be execute 8 now. Okay, so this is rather close to the way mathematicians define experimentation, and arguably describes the concept more clearly than the looping variant, and the function calls itself multiple times with ever smaller exponent to achieve the repeated multiplication. And both this implementation, by the way, has one problem in typical JavaScript implementations, and is about 3 times slower than the looping version, and running through a simple loop is generally cheaper than calling a function multiple times. And the dilemma of speed versus elegance is an interesting one, and you can see it as a kind of continue between a human and friendliness and machine friendliness, and almost any program can be made faster by making it bigger and more convoluted, and the programmer has to decide on an appropriate balance, by the way. And in the case of the power function, the elegant looping version is still fairly simple and easy to read, and it doesn't make much sense to replace it with the recursive version, and often so a program deals with such complex concepts that giving up some efficiency in order to make the program more straightforward is helpful. And worrying about efficiency can be a distraction is yet another factor that complicates program design, and when you are doing something that's already difficult, that extra thing to worry about can be paralyzing. And therefore, always start by writing something that's correct and easy to understand. And if you are worried that it's too slow, and which it usually isn't, sounds most code simply isn't executed often enough to take any significant amount of time, and you can measure afterwards and improve it if necessary. And recursion is not always just an efficient alternative to looping, and some problems really are easier to solve with recursion than with loops. And most often these are problems that require exploring or processing several branches, and each of which might branch out again into even more branches. And consider this puzzle by starting from the member 1 and repeatedly either adding 5 or multiplying by 3, and an infinite set of numbers can be produced. And how would you write a function that, given a number, and tries to find a sequence of such additions and multiplications that produces that number? And for example, the number 13 could be reached for first multiplying by 3 and then adding 5 to it, and whereas the number 15 cannot be reached at all. And here is a recursive solution, like this example now. Function find solution target, and function find current and history, and if current equal target, return history, semicolon, then else if current greater than target, and return null, semicolon, then else return find current plus 5, and $sign history plus 5, and find current multiply 3, and history multiply 3, and return find 1 and 1 between double quotation, and console.log find solution 24, and the result will be 1 multiply 3 between parentheses plus 5 and multiply 3. And you know that this program, by the way, doesn't necessarily find the shortest sequence of operations and is satisfied when it finds any sequence at all. And it's okay if you don't see how it works right away, and let's work through it. And since it makes for a great exercise in recursive thinking, and the inner function find does the actual recursing, and it takes two arguments, by the way, and the current number, and a string that records how we reached this number. And if it finds a solution, it returns a string that shows how to get to the to the target. And if no solution can be found starting from this number, and it returns null. And to do this, the function performs one of three actions. And if the current number is the target number, the current history is a way to reach that target, and so it's returned. And if the current number is greater than the target, there is no sense in further exploring this branch, because both adding and multiplying will only make the number bigger, and so it returns null. And finally, if we are still below the target number, the function tries both possible passes that start from the current number by calling itself twice, and once for addition and once for multiplication. And if the first call returns something that is not null, it's returned, and otherwise the second call is returned regardless of whether it produces a string or null. And to better understand how this function produces the effect we are looking for, let's look at all and the calls to find that are made when searching for a solution for the number 13. For example, find open parentheses 1 and 1, and find 6 open new parentheses 1 plus 5, and find 11 open parentheses 1 plus 5 plus 5, and find 16 open new parentheses 1 plus 5 plus 5 plus 5. Yes, it's actually 16. Too big. And find 33. 1 plus 5 multiply 3 will be 33. Too big. And find 18. 1 plus 5 multiply 3. Too big. And find 3. 1 multiply 3. And find 8. 1 multiply 3 plus 5. And find 13. 1 multiply 3 plus 5 plus 5. And found. The indentation indicates the depth of the call stack, and the first time find is called, it starts by calling itself to explore the solution that starts with 1 plus 5, and that call will further recurse to explore every continued solution that yields a number less than or equal to the target number. And since it doesn't find one that hits the target, it returns null back to the first call, and the concatenate operator causes the call that explores 1 multiply 3 to happen. And this search has more luck. It's first recursive rally call, and through yet another recursive call, and has opened the target number, and that innermost call returns a string, and each of the concatenate operators in the intermediate calls passes that string along, ultimately returning the solution.